So what we're going to do is we're going to tear down a brother printer that is a leftover from a job I used to have. The printer died and got stuck in a corner, and when I left them and brought everything back, I missed it. But it was shot anyway, so it doesn't matter. And we're going to basically check the bits and that's included. Now there's no carry case. I really wish this would be the perfect screwdriver if it had a carry case built in. Butt end sticking out. So this is the BezosMAX, and so we're going to kind of put this through some paces too. And what really makes this nice is just like this, in the case, everything boxed up with the butt end sticking out, you can charge it. And then kind of as a control, I guess, I've got this big old honking mammer jammer, which is, you know, the old school standard 1/4 inch bit driver. So this is a Brother MFC multifunction model MFCL2685DW. And the way it works is you start by pushing the button. You know, you can't hear it, but it's turning. Now it's going the other way. So you twist your hand. So usually when I'm stripping something down, I will just take every screw I can see as I go along. And I lost track of, oh, there it is. It couldn't get it out. So that leaves us with this one. And so this will give you an idea . And so this one got it out. This BezosMAX kit is pretty good kit if just for the accessories you get in it. But that's a whole assembly I'll just hold on to, because I could probably do all kind of things with it. You got gears and whatnot, you got C-clamps. Okay, so I'm not even going to bother with a whole lot of the other ones because they're just cheapos, and this is the powerhouse that will get any stuck screws. Okay, so I don't know if the camera overheated or what, but it quit recording. So anyway, it is what it is. I don't know what y'all missed. Probably not a whole lot. Probably fix to quit playing with this thing and just go to ripping it apart, because I don't know where all the little catches are. They're not exactly obvious. Although a lot of them are. So here's a lot of the wiring for the top section. So let's go ahead and get that apart. Okay, so this is kind of awesome. See what kind of we made. Oh, look, now this is amazing. It shows AC direct, relay heat, 8 volt, 24 volt, something, and 24 volt. So 8 and 24 volt for sure. And I don't know what other voltages we've got on this board, but it's pushing those out. So we will experiment on that a little bit, see what we've got. I don't see any more screws on top, so I don't think there's more screws for me to take out to further disassemble. Okay, so we left off yesterday. The battery died a couple times, so I lost a little bit of footage in the teardown. And you missed a ton. I solved all of the universe's problems. And I told you all about it, only the battery was dead and you didn't hear it. So I gave you the question and the answer to the question. So it's your fault. No, well, it's Sony's fault. Then I had something else that I was letting you know about. And at some point, the 64 gigabyte memory card filled up. And I don't hear good, so if that thing makes noises whenever it fills up, I don't know it. And so you didn't get all that. So you missed a ton of stuff. But now I've got a fresh 64 gigabyte card in there, and we're at it again. So the teardown's basically done as far as I'm going with it. Oh, my hat. It says Elite, and it's been around a while. So, I mean, it's all sweated in. But it's a $800 hat. This hat cost me $800. I'll let you figure out why. If you know, put it in the comments below. So, I've also got a hat that says Simmons Sporting Goods out of Louisiana. That one cost me $700. Figure out why that one did. I like hats. So, anyway. So, the teardown's done. I'm going to take and count up all the screws. And I'm going to put them in a couple piles right here. The ones taken out that the screwdriver went through, and it out of 1, 2, 3 out of 4 bars, it's got 3 left. That's where the screwdriver is. And so, I mean, this thing goes for days. The ES15S screwdriver, and I haven't even taken the plastic off of it, it's still on there, is an awesome screwdriver. I love it. It's my daily driver from now on. And we're going to kind of go through what we got out of that printer, and kind of go from there. Then we'll probably start on another project. Stick around, we'll be right back. Okay, so what we have here, this is the printer. Well, I mean, I have all the shell and everything over there, but I've got right here is the toner cartridge. There's a few screws left in it, and these were all coming out with this, but I mean, I didn't take them out. This basically is a pickup roller. I don't know what it's made out of, but it'll pick up the toner, and then that will, I believe it deposits it on this one, and then this by the way is magnetic. It's got a big old sponge on it, and I guess through the process somehow or another this becomes magnetic. Wait, Okay, I'm confused on which one. Maybe it's this one. One of these is magnetic. I don't know. I have to figure out which one. But I know one of the rods is always magnetic in a printer, a laser printer. And I have to dig it through here, and I don't really want to go through all this and get my hands dirtier than they are now. Because it's Christmas Eve, 2024. So here's kind of a breakdown of what I've got. Here is, it's 90 screws here, 40 screws here. So 40 screws were taken out with this one, and 90 screws were taken out with this one. And this one only dropped, the ES15S only dropped by 1 tick on the battery, and maybe you can see it. I don't know, maybe I can zoom in on that. You can see. And I'm going to kind of explain some of this stuff. This is just buku pile of gears and stuff here that I'm going to keep. Here's some worm style gears that goes with that one particular setup. Here's another gear. And so there were several of these, probably, and this is what I did. Okay, I figured, because I'm too lazy to go back and try to watch a couple hours worth of video to count them up to be sure. So I just said, okay, before I started separating the screws, I took 20 out with this, which I didn't. I took way less than that, probably about 10, but I doubled it. So you can probably figure it took out about 100 screws using impact over 80% of the time, and using impact in some cases 2, 3, 4 times, taking the screw out. And it only went down 1 out of 4. It only went down 1 battery level on the screwdriver. And so that's kind of how I figured out the screws. And all I used to take this apart was the ES15S screwdriver, the biggest cross hex bit or cross bit that it had, the extended cross bit out of the BezosMAX kit, this little pry bar out of the BezosMAX kit, and this. And then tool wise, all I used was these little tiny Harbor Freight cheap needle noses. I mean, give you an idea, this is how big they are. A straight screwdriver, because some of them, there was like 2 or 3 screws that were too deep for anything I had, and the hole was too small for this big fat one multi screwdriver to go through. And so that was it. That's the bulk of the tools. I didn't even get into this little cheap kit right here. So and I've probably got about 50, if I count all the itsy bitsies, I've probably got about 100 and something, but I'm just going to say about 50 gears here is what I ended up with. Now, all of these rods are precision ground. Quarter, no, this one's a quarter, and it's about a foot plus long, maybe a little over a foot long. This is somewhere between a 1/16 and a quarter. I don't know what it is. Here's another rod. It's got some shoulders and whatnot in it. Another rod here, but if I remember right, I think this is an aluminum housing on the inside. I remember this one now. And then I got to take the rollers off of this one, but here's another one, about a quarter. Here's another one that's more like a 3/8 or closer to a 3/8. Here's 2 more rods, and then I've got multiple small rods here, and then I've got 2 step rod, or little small step rods, multiple sizes. There's another little small rod. I've got a few I don't know, some kind of plastic rods. I've got a whole bunch of these little small ones that I broke off the side plate where the circuit boards and the gears and everything were mounted. Just more or less for pins. Of course, we got the main motherboard, which has got several Molex connectors. We got ribbon cable connectors. We've got a Bluetooth module. We've got a USB. I don't know, the fat one. I forget what it's called. The USB-B USB connector. This board is destined to become just a test board, sample board. I'll clean it up and use it just for demonstrations with soldering stuff. Of course, I've got these two. This is an aluminum tube. Needs to be cleaned up. It's got toner on it. It's got a gear on each end. This is a hollow tube, and I don't know, I've never had a use for any of these that I've taken out of laser printers, but one day I will. I don't know where they're all at, but I got them. I have a very hungry 24 volt DC. You know what? That is not 10. That is 1.10 amp. So it's 100 milliamp. So it's not really as hungry as I'm thinking. I don't know why. I looked at it. I guess I was tired yesterday. Anyway, so I got a 24 volt DC fan, which it's always handy to have fans of different voltages, because I've got projects where you're dealing with PLCs and different things. Hold on, let me turn the lights on. I can't never remember to do this the right way. So with PLCs and stuff like that, you will usually be dealing with like 24 volt, and so you already have it in that case, and you don't have to use a buck converter, or if you're dealing with a 12 volt system, a boost converter to use that fan. So if you got 12 volt, 24 volt and different voltage fans, that's like the upcoming water distillation project. I've got this old fan. It's a case fan for a Hoffman box, usually where you would install them in a Hoffman box. It's metal, got an arrow on it to show the direction of the flow. But this is 120 volt AC, and you just plug it into the wall and this baby hums, and these things hum like forever, non-stop. And so that's what I'm thinking about maybe incorporating into that project. So it's good to have stuff like that. And tearing these old printers and stuff apart, this is what you come up with. Now I have another printer. It's a fax, I think it's a fax printer, that's like sitting beside my shop out there, and it's outside. And so we're going to tear that open probably with one of the other screwdrivers, and I'll have to fight myself not to use the old miniware here on it. But and we'll see how it does with, because it's been sitting out there, oh man, probably 6 months. So this thing should be really goopied up, and so we'll see what we get out of that. Okay, so that covers those. A boatload of springs of all different kinds. You never know when you're going to need a spring for what and how. I've got this, which I call them click-ons. They're in washing machines, dryers, hair dryers, anything that gets hot, and heaters and stuff like that. And what it does is, this is normally open, normally closed. They come both ways. And I think Clix-On is probably a name brand, and this probably has another name, I don't know. But the thing about it is when this gets hot, the metal flexes and it changes state. So it either changes from normally closed to open, or changes from normally open to closed. However it is, that'll do it. And these are rated for, let's see, CH152. I don't see any actual mark. Here we go. This is a 0115235. I can look up that number and tell you what it's rated for, what voltage and what heat temperature. So when you buy these, you will buy them for your project. You want it to, it's going to have a low end and a high end. And so, okay, so here, in this case, as a scenario, a heater. When it gets to 200 degrees, you want it to cut off because you don't want it to get no hotter than that. So you buy one of these that's rated for 200 degrees. Okay, so it's also got a cool state. And so once it clicks at 200 degrees, it's got a period of time it's got to cool down to before it goes back to the other state. And so that's the other part of what you'll look at to buy one of these. And so you may want it to cool down to 150 degrees before it changes state. So at 200 degrees, pop, it does what it does. And when it cools down to 150, pop, it goes back to its original default state until it's heated up to 200 degrees again. And then it's just sitting there seesawing back and forth. And so that's what a click-on does. So you have these right here. That's a really good thing to have. In addition to that, of course, you've seen the power supply. So I've got multiple voltages here, and that's the casing and everything, and I'm probably going to put that in some kind of, maybe even 3D print something and mount all that in there. And I'll have a nice little power supply, and that'll probably be a project in and of itself. And then we've got some belt for whatever. I mean, I don't know, for whatever project it comes out to. I just unclip it from here and probably throw this piece away, don't need it. But I'll have the belt to work with gears and stepper motors. And then I've got a couple of these that come out of this assembly. Now what this assembly, let's look at this for a second. So this is the heating element. This is a glass bulb. I'm pretty sure that's probably a halogen bulb. I can touch it, heat it up, and it'll blow up. Not a huge explosion, just go out. It won't work no more. And it goes up inside here, and this barrel heats up, and that's what fuses the toner to the paper. And so you got this. What it accomplishes, I don't know. What you get out of it, I don't know. What I can do with it, I got no clue. But I got it. That's the most important thing. I got it. And so I'm going to leave that in that tube, try to put that up and take care of it. But also in that, I had these two little deals right here. Now both of these, to a certain extent, remind me of a mass airflow sensor on the intake of a vehicle. Of course, but they don't allow air to flow through them and across these sensors, so that's not what they are. I think there's some form of thermal switch sensor thingy, which I'm going to look up and see if I can find numbers on these and try to find out what they may or may not do. I don't see numbers, but I'm going to try to treat them with kit gloves until I know what they are and if they're anything that I could possibly use at some point. So I've got those, and then I've got a bunch of these. Let's just take that loose. I've got a bunch of these here. Let me try to collect up a handful of them here. There may be more on here, I don't know. But, oh, that's a nice one. We'll talk about that in a second. So, all of these, it's 1, 2, 3, 4, 5, 6, 7. So, I've got 7 little infrared sensors here. Same thing like what you'd see in a mouse or whatnot. You block it, and it gives a signal. I have to find out what voltage it needs to go to it to get a signal, or exactly what is required, but that's part of all of this stuff. You get to figure that out, and that's neat. And so I got a bunch of these right here. That's awesome to have those. And then I had this. I wasn't expecting this, but I should have. This right here is a thermal sensor, and I don't know the details on it. Maybe I can find something that'll tell me something about it. But this is like a, I want to call it a a K-type thermocouple, but I don't know what it is, but I know it's a thermocouple. And so this will change its, this is either going to change its resistance, I believe, with how much it heats up. And so you get, through these two here, a temperature reading or resistance reading back to your circuit, which you extrapolate or interpret into a temperature. And this is the sensor that's used in stuff to find out what temperature it's at. And so this I can see a lot of uses for. So this is going to kind of be, you know, kind of rat-holed off the side for when it's needed, at what point. We got of course we got a bunch of ribbon cables with flat ferrite beads. I keep calling them beads, but just flat ferrite whatevers. And I got to find all of those, collect them up, because I need to clean this up to start the other project. But we got a little speaker, probably a little nothing, but it could be used for something. I don't know. I'll keep it until I get tired of keeping it, and then I'll get rid of it. And so then we got this. Oops. These are pancake. No, it's a stepper. These are pancake DC motors. And there's only 2 wires going into them, and so these are just going to spin for as long as they spin until you tell them to stop spinning. They probably don't have a lot of torque. Who knows? But they were functioning some part of it, so I don't know how good they are or what they can do. But I have 2 of those for some projects. And then I have 1, 2, 3. So I have 3 stepper motors out of there. One of them is a really flat pancake stepper motor. This one's a little thicker, probably twice as thick as that one. And then this is a big old stepper motor, like what you'd see in the old VCRs, spinning the head on the VCR. Yeah, I've tore a lot of stuff apart. So I ended up with 3 pretty cool stepper motors. Not nothing you're going to actually do worldly stuff with, but it could be great. I mean, look what they did with them in a printer. And so there's a use case for them. So I've got that. Now this one, let's hold off, because this one's going inside, and we're going to go under on the bench and get into this one probably tonight before I go to bed. Here is another ferrite, and this is the and I don't know if this is a full fax machine or if this is just a phone interface, possibly. This right here is a light bar. I don't know what it takes to run this thing, to get it going, what kind of voltage, probably more than I want to deal with. But we might can do something with it. This is on top with the scanner. This would run back and forth and scan your page. And then we've got this interface board, which I just left it together to keep all of the buttons and stuff intact. You got a little LCD screen, a bunch of buttons, and the reason why I left it together is because the circuit board on the back is just I guess carbon contacts, and then these buttons go down and touch that board, so there's not really a button underneath here, so it really doesn't. And most of your printers and stuff like this are like that. It's not really a button you're going to get out of any of this stuff. Okay, so here we are. I said we'd take a look at what we got here, and that's what we're going to do. I'd almost say that's a stepper motor. I'm not entirely sure why. I mean, I wouldn't think that it would need to be a stepper motor. I would figure it would just spin at a set rate. You can see this one is kind of mountainy shaped, and that's what it is. I mean, these right here and this one back here are about, I'd say, at least a ½ inch thick. I know this is mirrors on this right here, and that's some kind of, these right here is got to be some kind of mirror here, a mirror here. These crystals here, or I say crystals, I mean they're focusing whatever. And and I can't tell if there's mirrors on this or the back of this is a mirror or exactly what, but it just bounces the laser all around inside here. And this particular laser right here is strong enough to
Look what I found in the back of the van.
hold on. That's one of the legs.
I'm going to drop it off and...
Okay. Excuse me, I delivered Christmas presents after the grandkids went to bed, and apparently there was a piece left in the back of the van. So anyway, I have no idea how this works. The laser sets the toner on a drum, like the letters, the words, or whatever. How all that's interpreted into here and the laser does that, and how all this works, I don't know. I just know I've got some laser mirrors in here, some focusers, whatever you want to call them, be they crystals or whatever, and I'll probably just keep all this in this until I want to try to experiment with it. But I think I can probably do something with that laser. I just have to figure out voltage that I need to put on it and exactly what. But I would assume, being as the power supply that was in the laser printer, I know it had 24 volt and 8 volt supplies in it, or taps, or whatever you want to call them. And so I would assume, and I would expect to see 12 also. I don't know. There was more than that. I just couldn't read them. The circuit board was so small. So when I kind of fill that power supply out and make it into a power supply, I'll make sure that I make a list of each one of the taps coming off the power supply. And so I would assume this is probably somewhere between 8 volts and obviously 24 volts. So you know, we'll figure that out when we get to playing around with this. I just thought all this stuff was cool with the magnifying glasses and the focusing crystals and the mirrors and this thing, whatever it is. I thought it was all kind of cool. I thought I would, you know, just kind of let you see this. And I mean, give me some ideas what you think we can do with this. Or so I appreciate you sticking around. I thank you for spending your time here with me. I hope you show back up again and we can spend more time together. Thanks. God bless.